Hello and welcome to Math Matters. I'm Ms. Granados and today we'll be learning more about finding the mean, median, mode, and range of a data set. In today's lesson, we'll be looking at data and reviewing what we've learned the last couple of weeks about some measures of center. In other words, the mean, median, and mode. We will also review the range as a measure of spread. As you review this content, you will be using the Portrait of a Graduate skills of communicator and creative and critical thinker. You might communicate during this lesson orally to someone near you or when you write down some of your thoughts. As you work through some of the problems in this lesson, think about being a creative and critical thinker by asking questions to help you solve the problems. Just like in previous lessons, you will need some paper, something to write with, and a calculator. So go ahead and gather your materials and come right back. Would you rather play for the Jaguars basketball team, who had a record of 7 wins and 5 losses, and scored a mean of 107 points per game, or for the Wolves basketball team, who had a record of 9 wins and 3 losses, and scored a mean of 65 points per game? Whichever answer you choose, justify your reasoning for selecting that team. In other words, explain why you selected that team. Write it down or tell somebody near you. Thoughts from 3 students. Rachel said she would rather play on the Wolves because they have more wins. She doesn't really mind that the mean score is lower than the Jaguars' mean score. She'd rather have more wins than more points. Ed said he would rather play with the Wolves because he likes to play on a team with a strong defense. If a team has more wins with lower points, then their defense has to be pretty strong to keep the other team from scoring more points. Allison likes to score a lot of points, so she would rather play with the Jaguars, who have a higher mean score than the Wolves. Did you have any of the same thoughts as these students? Okay. 10 fifth graders went to the doctor's for their annual checkup. This table shows the weight in pounds of each of those students. What's the average weight of a 5th grader? Well, to answer that question, we could be looking for the mean, the median, or the mode. So why don't you go ahead and find all 3 and see which best answers what is the average weight of a 5th grader. I'll give you about 2 minutes to find those measures of center. Alright, let's start with the mean. To find the mean, we need to add all the values and divide that sum by the number of values, or by the count. In this case, the total of all the values is 760. There are 10 data values, so that means we have to divide 760 by 10, which would give us 76. Therefore, the mean of this data is 76, which, in this context, signifies that the average fifth grader weighs about 76 pounds. Moving on, we can find the median only after we organize the data into a list ordered from least to greatest. Once we create the list, we can start crossing off the least value and the greatest value. We are left with two values, 74 and 78. So we need to find the number that is exactly in between both of those numbers. I can do it one of two ways. First, I could find the mean of the two numbers. Their sum is 152, and then I would divide that sum by 2, which gives me 76 as the median. Or I could use a number line to find the median. In this case, I can take 2 jumps from 74 to get to 76, or 2 jumps from 78 to get to 76. So I know that 76 is exactly in the middle of 74 and 78. The mode of a set of data is the value or values that appear the most number of times. It may be helpful to arrange the data values in order from least to greatest. I use the same list I created to find the median in the last slide. Now that I have a list in order, I can see if any of them repeat. I see that only 78 repeats, so that has to be my mode. So we figured out that the mean of this data is 76 pounds, the median is also 76 pounds, and the mode is 78 pounds. All three measures of center are close to, if not the same as each other. So what does this information tell us about these fifth graders? Something we can say is that these fifth graders weigh between 55 and 109 pounds. The range of this data is 54 pounds. In other words, all 10 students weigh within 54 pounds of each other. This is something we can state based on the data we have. Can we say that all of them weigh about 76 pounds? Not really, right? Only Joshua, Carol, and Samantha have weights in the 70s. 4 students weigh less, in the 50s or 60s, and 3 students weigh more, in the 80s and 100s. The mean, median, and mode tell us the center of the data, but as we can see, there are data values that are greater and less than that center. What we could say is that the average weight of a fifth grader is about 76 pounds. Can we say that only Joshua, Carol, and Samantha are healthy? Well, we're not sure. Health depends not only on weight, but also on height. Elena and Chloe, who weigh the least, may be much, much shorter than Rylan, who weighs the most. All of them may be healthy for their height. Health also depends on how a person is growing over time. And data usually doesn't mean much on its own, but rather when you compare it to other data. If we had the weights of these same 5th grade students from last year, we could compare the mean of that data with this data's mean to see how much their weight has changed. Let's look at another context. This line plot shows the height of 14 5th graders in inches. Each X represents one student. Take about 2 minutes to find the mean, median, mode, and range for this data. figure out the mean, did you add up all the values and get 798? There are 14 data points, so we need to divide 798 by 14. That gives us 57. Therefore, the mean of this data set is 57 inches. There are more x's above 58 than above any other number, so the mode is 58. What does that mean? It means that there were more students who measured 58 inches tall than any other height. To find the median, we need to put the values in sequence. On a line plot, the data is already organized from least to greatest. We can start crossing off the lowest and the highest values until we are left with one or two values in the middle. Here we can see that we are left with 58 and 58. Since both numbers are the same, we can say that the median is 58. If the median height is 58, that means that exactly half of the students measured less than 58 inches and half measured more than 58 inches. The range is the difference between the greatest and least data values. In this case, 66 is the greatest value and 48 is the least, so the difference is 18. The range is 18. Well, what does that mean? It means that all the fifth graders in this data set are within 18 inches of each other's height. Now we're going to look at a different context. During this quarantine, there's been a large demand for toilet paper. So I asked 14 people how many extra rolls of toilet paper they had in their house right now. The numbers they told me are listed in the stem and leaf plot. Take about 2 minutes to find the mean, median, mode, and range for this data. Let's talk about what you found. Let's start with the mean. Did you add up all the values and get 518? And then did you divide 518 by 14? So you must have gotten 37 as the mean. Great job! For the median, we know we have to organize all the data from least to greatest or greatest to least. Well, thankfully, data presented in a stem and leaf plot are already organized in order. If we cross out the least and the greatest values and continue until we're only left with one or two values, that should give us the median. In this case, we're left with 23 and 24. The number exactly midway between those two numbers is 23.5. So the median of this data is 23.5. We can see clearly that there are more 9s in a row than any other number. Since those 9s are all in the stem row of 2, we know that that value is actually 29. Therefore, the mode of this data set is 29. What about the range of this data? We see that the greatest value is 66, and the least is 6. We know that to find the range, we need to subtract the least value from the greatest value. So 66 minus 6 equals 60. The range of this data is 60. What does that mean? Well, it means that the data is spread out over 60 roles. That's a wide spread. When the highest number of roles in the data set is 66, a spread of 60 is a lot. There's a significant difference in how many extra rolls of toilet paper different households keep. Some hardly keep any extra rolls, like 6, and others keep a lot more, like 66. We don't have any information here about the reasons behind this difference, but we could think of some. Maybe the number of people in the household, or the number of bathrooms in the house. Also, the amount of storage space or extra cash to buy more than just a little bit extra may explain the difference. But just by looking at this data, we can't know for sure the reason. We just know that there's a large difference in amounts of extra rolls of toilet paper people have in their homes. Let's review. So today we looked at the data for the weight of 5th graders presented in a table, the height of 5th graders presented on a line plot, and the number of extra rolls of toilet paper people have in their home presented in a stem and leaf plot. For all the data, we calculated the mean, median, mode, and range. We looked at what the data might tell us about 5th graders, or about people and their stock of toilet paper. Tomorrow, we'll continue looking at data and try to draw conclusions about what that data is telling us. Here's the learning target for today. Some of the skills you may have used today include those for a communicator and for creative and critical thinker. In your notebook or on some paper, write down something you learned today and something you may still be wondering about. Have a mathematical day and keep on counting.